I am a telecommunications network operator. Need to figure out how to improve our network. We've got a few problems, an issue with operational degradation, and it could get worse with equipment failure. We need to come up with a plan to improve the network on both dimensions. So we're going to do that by using relational AI. We're going to build an ontology, reasoning to predict likely network equipment issues, understanding failures, what's at risk, do a rules-based analysis, equipment health, and which equipment we need to restore. Graph analysis to look at subscribers and understand influence and impact, gauge where we need to focus. We're going to optimize our tower upgrade selection so we know where to invest, and we're going to end up with a restoration plan that we can integrate back into our ontology and get to work. So let's get started. We begin by building an ontology to represent our network, representing regions, towers, subscribers, and other concepts and relationships. We've done a couple initial queries. Cell tower degradation worse in the West. Given our business problem, how can we answer reasoning questions and come up with a defensible upgrade plan? The discovery skill returned a potential chain to help us with the allocation problem, going from rules to prescriptive. And actually, we already have a predictive question in mind in line with this, looking at failure probability. So we're going to start there. The agent is helping us game plan a predictive analysis using graph neural networks. We know predictions of failure intensity and probability of failure for the different towers in our network. So we can proceed with a rules analysis. It will help us flag which towers are critical to restore. A lot of the towers are flagged for restoration. So we're going to have to do some prioritization here because we have a finite budget. But of course, our business isn't just about the infrastructure, it's also about our subscribers. So we're going to look at the impact of these failing towers on our customers and use that as yet another input to our allocation plan. Thanks to graph reasoning, we now understand which subscribers are most influential and most important to keep happy, and the blast radius of the different towers. The inputs for both probability of failure and consequence of failure will formulate that problem. All three of our reasoner outputs will be inputs to this optimization. If a tower is critical to restore from a rules analysis, failure intensity from predictions, and blast radius based on customers, and the graph analysis, so consequence. The run with the integrated solver completed, and we have a proposed plan for where we want to focus our upgrade budget. Now analyze the plan, see which of the constraints are binding, budget and install weeks, look at the economics, and then start to think about some scenarios where we could potentially look at alternative plans. So notably, we don't have enough budget to repair most of the towers, so this is why the prioritization on those different dimensions was so crucial. Let's do a quick what-if analysis. What if we added let's do a quick what-if analysis. What if we added another $1 million in budget? More budget bought us upgrades, improvements to towers we're already upgrading, but it doesn't actually add more. Just to show this is all code under the hood. Here's what the ontology we generated looks like, extended with rules and validated, and then the prescriptive problem, which is then integrated back into the ontology. Restoration plan. So these are our solutions we can now share with the decision makers. We ran one last scenario to see what's unlocked if we also have more crew weeks available, and this buys us the ability to restore more towers and upgrade them. So we have a few different framings on the different levers we can pull in our decisions, and these solutions are available for downstream folks. Pulled them from the solver, integrated them into the ontology, and now they're queryable with full information, fully integrated all the way from graph rules and predictive reasoners into prescriptive, and now we can pass it back to those downstream reasoners, rules, graph analysis on those solutions. So this allows us to keep building our ontology, and you can see how within a day, you can easily arrive at solutions for complex planning problems like this telecommunications network.